here we go. Okay. Oh, if I see, hey, Rena, go sit down. Let's go. Okay. I want to see on the test tomorrow, you want to do the easiest thing possible, right? If you draw yourself two triangles, right, I would want to use similar triangles to solve them. So in this question, this is a similar triangle question, where it's just asking you for the scale factor. It's not even like doing any thinking. You should just already know that if it's asking me for the scale factor, I'm just going to solve, right? So you're going to pick two side lengths, right? You're going to divide them. That's equal to 3. So the scale factor is 3. Okay, sorry. It's 3 or what, Nora? Good point. Sorry. You're right. 7, sorry. So that's 3. Now, did I go from the bigger to the smaller or smaller to bigger? So I went bigger to smaller. So in actuality, you could actually have 3 or 1/3, depending on the direction that you go. So if I go from the small one to the big one, I'm going to have to multiply by 3. And if I go from the big one to the small one, I'm going to basically multiply by 1/3 or divide by 3. Yes?
Do we have to say both of those?
Yeah, let's say both. That's good. Let's say both. That's nice. Okay? All right. So here's the catch for the second question. The problem is you're looking for side length DE, right? But the problem is you don't have AB accordingly, right? So you could do one of two ways to do this, right? You could choose to find DE first and then use your scale factor to find AB, or you can find AB and then find DE. It doesn't matter to me, but regardless, you still need to use a squared plus b squared equals c squared, right? You're going to find the hypotenuse because it's c, right? So let's plug in the two other side lengths, and it doesn't matter. Both of these you could kind of consider c. They're the hypotenuse, right? So we're just trying to solve for the hypotenuse, c. So you're going to plug in the two side lengths. We'll do the smaller one because the numbers will be smaller. 7 squared plus 5 squared is equal to c squared. Okay? Which means we're going to get 49 plus 25 is equal to c squared. C is equal to the square root of 74. Okay? Are we okay? Now, you can do one of two things here. Doesn't matter to me too much. You could do this again. Okay? Do Pythagorean theorem again to find the other one. Or, what would be faster is to get an actual number for root 74. So, that number is what? Does anybody have that number? By chance? What's the square root of 74? 3.6? What?
8.
Sorry. 8.6. So this is actually equal to 8.6. How do I get from the small triangle to the big one? Times it by 3, because we said the scale factor was 3. Is that okay? So that's side length AB. I think this is the faster way to do it. Let's just go AB is equal to 8.6 times 3. What's that equal to? 26 something? I'm guessing. Not bad, eh? 25.8. I guess 26. Okay? Are we good? That's just similar triangles, okay? Just find scale factor. Then you can find side lengths between two two similar triangles using that scale factor. That's faster than using all the Pythagorean theorem or SOHCAHTOA. The whole thing is 3 times bigger. Just multiply everything by 3. Okay? Here we go. Mr. Mackay is standing at the CN Tower on a sunny day. Is he what? In the shoulders, maybe. But that's only because the CN Tower narrows by the top. So here he is. I'll draw the arm since it created such an uproar last time. Right? And then he creates a shadow on the ground. How long?
4 meters.
4 meters. Right? And then how tall is he? 1.9 meters. Okay, and then we draw the CN Tower. Right? How long is its shadow? We don't need a lot of room, is why I'm drawing the picture so funny. How long is the CN Tower, or how long is the shadow?
1,229.5 meters.
Okay, so I have 2 similar triangles. Okay, because I've set them up that way. How many times bigger is the triangle on the right than the left is the question. Okay, it is a lot. I'm going to shrink these down. I need more room than I thought. Okay. How do I figure out how much bigger it is? Scale factor. So let's find the scale factor. Right? I'm going to find the 2 shared side lengths. They're the ones that look similar. Right? And you could do one of 2 things. You could divide them, or, well, yeah, it just depends on which one you put on top. So I'm going to put 1229.5 on top, and I'm going to divide by 4. That's going to give me a number. Who has that number? $307.4, is that okay? That'll be a scale factor?
Yep.
Okay, so am I going from a smaller triangle to a bigger triangle? That's what's happening. So what am I going to do to the side length here to find this one? Because that's going to be the shared side length that I'm looking for, right? So what am I going to do? Multiply it. So 1.9 times 307.4. That's going to be the height. Height CN. What do we get?
584.0125.
Therefore, okay. Any major concerns with that question? That was pretty much a homework question, I think. I read out of the textbook, except I put my name in there instead. Yeah, I'm all about that. It's all about me, buddy. Sarah?
Is that actually how tall the CN Tower is?
I have no idea.
Is that actually how tall you are?
Yes. It's on my driver's license.
I remember on my.
Yeah, write it on your list, boys. Get ready. The only last thing you need is my social insurance number, apparently.
On my quiz, I literally wrote the calculus for that. Can we get your credit card?
No, you can't have that either. Okay, is everybody okay? You want to do similar triangles where you can do similar triangles. Why do you want to do SOHCAHTOA, sine law, or cosine law if you could just do a similar triangle? I don't want to do that.
It's just like unexpected. You know, it's unexpected that it's just like that easy.
It is that easy. Well, the whole trigonometry unit is structured in a way that you're doing the easiest things first. Cosine law is the last thing we did. You don't want to do that. You use it in a last resort. If you see a 90 degree in the triangle, use SOHCAHTOA. Don't use sine law. Certainly don't use cosine law. It's SOHCAHTOA or Pythagorean theorem. Okay? Now, let's go down here and look at this question. This was mixed bag as to how it was done. Okay? For the reason of some people just chose not to do the other half of this question. Okay? Let's deal with one. Okay, so I see two angles here. Theta and alpha. You have to write the primary trig ratios for both of them. I even bolded it. I don't know what I have to do. Like, I can't make it jump off the page. So I bold it so that it grabs your eye. Yet, some of us choose not to do both halves. Don't know what that's about. So, let's do all the stuff with theta first. But with theta, I'll do it in red because I highlighted the angle red. If I'm standing at theta and I look across, the 2.5 is what? Opposite. Very good. Okay, that's important. You're standing at that angle in particular and you're looking across, that's opposite. Some of you are labeling it adjacent and then the work's all right. You've just labeled the triangle wrong. Okay, that's an easy fix. Okay. If I'm standing there, then that must be adjacent, the 5, the side by side, right? And then hypotenuse is always the longest one. Right? So, then I'm going to write all the trig ratios for each of those for theta. So, sine theta is equal to, it says do not solve, so do not solve. I don't care what theta is, just write it down as the trig ratio, the fraction. Ratio, remember, for fractions, right? So sine theta is equal to opposite over hypotenuse. Fill in the numbers. 2.5 over 5.6. Next, cosine theta equals adjacent over hypotenuse. Adjacent is 5 over 5.6. Next, tan theta is equal to opposite over adjacent. 2.5 over 5. That's theta, 3 marks. I also asked you about alpha. Let's do that in blue. I'm going to erase the arrows and all the red writing, because it's all going to change now. Now, I'm standing at alpha now. I look directly across from alpha. What side do I see? 5. That's opposite. Beside alpha, or adjacent, is 2.5. And the hypotenuse is still the hypotenuse. Write the primary trig ratios for alpha. Sine alpha is equal to opposite over hypotenuse. Opposite is 5 over 5.6. Cosine alpha is equal to adjacent over hypotenuse. This is 2.5 over 5.6. And the tangent of alpha is equal to opposite over adjacent, which is 5 over 2.5. That's it, guys. 3 marks each. That is a very important skill moving forward. It's just being able to, actually, that's a grade 11 question, is writing primary trig ratios, right? And then I throw a wrench in it and say write the reciprocal ones, which you don't know. That's the cosecant, secant, and cotangent on your trig table. It's really actually quite straightforward if you can do that.
Wait,
There
what
were
are the
kids.
uses for those three extras that Cody handed and all that?
Huh?
What are the three uses for them? Like, what do they use for them?
They're called reciprocal ratios.
Oh, so it's like is it the inverse?
Yeah.
Oh.
We're not going to do that. But anyway, I've given this question in the grade 11 class, and kids can't do it. Right? You guys have now seen it. Okay. Is that okay? Any questions? This is an important skill. Let's solve for the unknowns. Okay. You are interested in angle X. It's on the inside, so it's an angle. That's what we're going to try solve for. Sorry. X, I'm standing here. Oh, I don't need two X's. You're standing at X. You look across, you see opposite. The side is going to be adjacent. I don't really care about that one because it's not asking me about it. And the 12 is hypotenuse. You want angle X. Right? So I'm going to write SOHCAHTOA because I see a right angle in the triangle. Right? Which one uses the two pieces of information that I have? I know opposite. I know hypotenuse. I'm selecting sine. So I'm going to go sine X is equal to 5 over 12. Right? 5 divided by 12 is what? 0.4167, we'll say. You can go to your trig table, find this decimal number or something very close to it. Read off the angle. You should see angle X is equal to, it's closest to 25 degrees. This time, I'm looking for side length X, right? I'm standing at the angle. I'm going to look across. Side length X is opposite, and this is adjacent. So I'm going to go, what am I going to pick? So from SOHCAHTOA. I have the angle, so that doesn't help me. You're going to pick a trig ratio or a trigonometric function. But you need to select the correct one that uses the thing that you're looking for and the piece of information that you have. I see that I have opposite, and I see that I have adjacent. O and A from tangent seems to be the most appropriate. So I'm going to go tan of 30 is equal to X over 10. Solve for X. Tan 30 is equal to X. Go to the table, find the tangent of 30. You should see it's something like 0.5774. That's equal to X. X will equal 5.7. 5.8 if you round. Okay? Please use SOHCAHTOA if you see a 90 degree in the corner. If you see a 90 degree in the corner, please use SOHCAHTOA. Do not use cosine law. I will throw your page down the stairs or something. I don't know. It'll drive me nuts. I do not want to mark cosine law 4 times. That's the other thing. It's a disaster to look at. Right? It's hideous. It's not the prettiest of math equations. Okay? Do the thing that's easiest. We did the unit in order for a reason. Okay? Let's go last question. Again, we get to see everybody's ability to draw pictures. That's great. Fabulous. Okay? So, here's your lighthouse. Saw some great lighthouses. Even had some like spirals on here. And even on the top, they had some nice lights going on. It was quite nice. Okay. Along the bottom, we've got our water. It's actually a frozen ice sheet. And we've got our boat stuck in. No, I'm just joking. Okay. How far is the boat from the base of the lighthouse? 900 feet. Okay, most people did not have an issue with that. Right? Here's where everybody decided to go, I'm going to do whatever I want. The line of sight from the boat to the lighthouse. We talked about this morning. Here's my horizontal, the blue dashed line. Angle of depression says I measured down from the horizontal. 12 degrees. That makes the inside of the triangle 78 degrees. There's a 90. You did the math on this. This would be 12 down in the bottom. Now, you care about X. How tall is the tower or the lighthouse? Right? So you could do this one of 2 ways. If you didn't recognize that this was 12, then you could pick this angle. Some of you decided to do whatever you wanted, and there was just like angles all over the place thrown in trig functions, and it worked out because maybe you made a mistake with flipping of something. Okay. Huh? There's no coleslaw sandwich here. No, we're not making coleslaw sandwiches from nice 90-degree triangles because SOHCAHTOA rules. Okay? I'm going to say let's stand here at the 12 and look across. What do I see? Opposite. I see the lighthouse. It's opposite. Okay? Which makes the 900 the adjacent piece. If I write SOHCAHTOA, I see that I have opposite, or I'm looking for opposite, and I have adjacent. That sounds like tangent. Okay? So, let's pick tan. Tan of 12 is equal to opposite over adjacent, which is going to equal x over 900. So x is going to equal 900 multiplied by the tangent of 12 multiplied by 0.2126. Therefore, yes,
I got that answer, but I inserted well on the outside.
that's why you lost marks, my friend.
But how did I get the same answer? But
Because you flip something.
also your computer.
I feel like it probably would have said low a while ago. How come? Do you guys not? Oh, it doesn't show you that. Okay.
I think it just doesn't like.
No, I just don't plug it in. Is 191.34 feet. Okay, that's it for that quiz. Any questions?